Hello, hello. Can you hear me? Is anybody here? If you can hear me, then please write something in the chat. Like yes, or I can hear you, or something like that. Okay. Seems that we can start. So, hello and welcome. The first and probably not the last webinar organized by the Vincit team about well, this one is about behavior-driven development. There will be more about IT in general, but yeah. So, okay, without further ado, I think we can go in. So yeah, BDD, why even bother? Why and how test software behaviors in mind? I think that this title says everything, so let's just go in it. Okay, so at the very beginning of every presentation, list in this industry, the person should present its credentials. So I will do the same. So my name is Łukasz. I've been working in this industry for more than 7 years right now. Yeah, I started with nothing, with zero knowledge and zero experience, and I had to taught myself basically everything via every source possible. Yeah, I've been working for e-commerce. I've been building web apps. I have some limited experience with game dev. Right now I'm also mentoring a small group of people. And this little webinar is, let's say, a little block in that mentoring structure. But also, which I think is the most important, I'm not a BDD specialist. I'm not, let's say, certified. I don't have that much experience like a lot of people in the industry. This is not, let's say, my main area of expertise. Yes. Which, of course, begs the question, why this topic specifically, if that's not my expertise, if that is not my specialization. And the reason is very simple. Because at some point I tried to learn what BDD is, what TDD also is. I tried to learn, and BDD is like the natural extension of that. So I tried to learn what that is. I found some books, which helped a little bit, but not to the greatest extent. So I thought, okay, I will go to the internet and I will check what is there in store. And after going through a few pages of Google results, after checking a few materials out there, I realized that something is not right. I mean, a lot of materials, especially on the first pages of Google, will tell you how to set up everything, how to prepare for testing, what TDD in general is, what BDD in general is. But after that, when you want to know a little bit more, when you want to dig in a little bit more, there is a surprising lack of few very important informations in those materials. It's surprisingly hard to find a few bits that should be, in my opinion, in every tutorial about BDD and TDD, but there is nothing. So I decided to do this little webinar to explain that little point, or a couple of points. Basically, what the most important reasons why BDD even exists, why we should even use it, because things like testability, maintability, etc., those are all fine and important, but in my opinion, those are not the most important when it comes to testing software. So yes, so this webinar is about those fine points. So I can tell you about all of those, and just then put it on the internet for the rest of the world to see. Okay, but for at the beginning, a little refresher. I mean, I'm assuming most people listen to this understands what TDD is, but let's just go through it really quickly to be sure that everyone is on the same page. So the idea is pretty simple. Yes, we don't in the, let's say, standard way of making software, in the way of making software that people are taught in the boot camps or when they are trying to learn programming themselves. The idea is that they will sit down and just write the program, and that's fine. I mean, this is the most basic, let's say, classic way of doing things. Meanwhile, TDD states that yes, you will write program, but before that, you have to write tests for this program. So basically, first you write a bunch of software that will make sure that the final version of the software, let's put it that way, will work as intended. It's like a safety net that we create before going through the, let's quote unquote, real work. And TDD has a very simple cycle. So called red green refactor. Basically, we write tests. We make sure that those tests fail, because that's the basic idea. We first write all the tests necessary for the software that we want to write, for the situation that we want to have it, for the situation that we want it to work with. And only after that, we make test pass by writing the software itself, by writing all the functions, all the classes, etc., etc. And after that, which is arguably the most important part, when all the tests are green and everything works as intended, we refactor the code. Because that's another thing about tests. They are not only here to make sure that the code works, they are also here for us to be sure that the next iteration of the code will also work, and then one after that and the one after that. It's the safety net, not only for writing the soft itself, but also making sure that the soft will work also later, will work after our changes, after changes made by some other part of the team, made or maybe by ourselves 1 year later or 2 years later. It's a very broad safety net that exists for should exist for quite a long time. So a simple example. We want to add one number to another. So we want to write a simple function that will do that. How are we gonna do that? Well, we first write test. This one is written using Jest or any library that with similar capabilities and syntax. Basically, describe is a block of tests, and the test is like a single test. Yes. So for the method add, because we will call that method add, we write one test, and we expect, this is our assertion, that this method, when I give it 2 and 3, it will return 5 to me. That's basically it. And after having this test up, after running it, after seeing the red information about how it failed, we then write the method itself. In this specific situation, as you can see, it's simple function. It takes 2 arguments and it returns the sum of those 2. That's basically it. Now, this specific example is a little bit contrived because it's much easier to just take 2 numbers and sum them. Yes, to write a plus b inside the code. Like, what's the point of even going for a separate function for that? But this example, apart from being contrived, is also pretty brilliant because it's very simple. It shows how the idea even works, because there is really nothing here to add and nothing here to remove. It's a simple function. It takes 2 arguments. It returns one value, and that's it. So writing a simple test that will explain how TDD works is banal. It's very easy. But this example is also pretty brilliant for a different and not very apparent reason, at least not apparent at the first glance, because if we treat the add method as something that just exists inside the code, as something that I would just want to use somewhere in my code, then what you see in the screen is all. You don't need anything more. But that add num method can also be more complicated in usage. Like maybe we need this method to some values from a few different inputs. Like user changes value in one input, we pass it to the code, and that code uses add method to add that value to the existing sum from previous inputs. Or maybe it's a part of the API, maybe it's a part of some library that also is here to sum those numbers. Now, in this situation, we have to think about it a little, because when the code is written by us for us, we can assume that both arguments of that function will be numbers, and that's it, because we will know also about that, we will remember that. But when it comes to APIs, when it comes to methods and functions for the more, let's say, complex applications, this might not be enough. And this is when TDD shines, because in situation like that, the test battery may look like this, because yes, there is a chance when you have an add method as an API, as a library method, as an external method, that maybe at some point someone would like to, or will pass a string to that method, or maybe two strings at some point. So when writing that method for ourselves, it's easy to just go number, sum, and one test for those. But when that method is exported somewhere, when that method is for someone else, maybe it is more, maybe there is a reason to think about all the situations that can happen and then write tests for those situations. Because this is one of the reasons why TDD is so powerful, because you have to sit down and think about those. You have to ask yourself a question or two about how this code will be even used, where it will be used, by whom, what situations can occur with this code. One can say that no, there's a low chance that someone will try to pass strings, the method that will sum values. But remember, JavaScript is a dynamic typed language. There is no types can change, and they can change in a very I don't want to say random manner, but there is a good chance that the type that you think you will get from somewhere will not be that type. There is a chance that you will get value from a few inputs and will try to sum them, and you will get different results from the one that you think you will get because of dynamic typing, which is one of the reasons why you might want to have a test that will check those, and then implementation for those situations. So yeah, this is one of the reasons why TDD as a tool is that very powerful, because it forces you to ask yourself some questions, and not only that, also to give answers to those questions, because you can ask yourself, well, is there a chance that user will pass strings to my method? And you will say, no, there won't be, and you will just leave it at that. But in this situation, you will have to make a test that will take into consideration that maybe, just maybe, there will be a string somewhere in your in your code that will be passed to the add method. So this is, in my opinion, one of the more important things. Not that, I mean, yeah, code will be easier to test with TDD. Code will be easier to maintain, but most importantly, code will be better thought out, because you will be forced to do that. Okay, So what's BDD at this when you consider all that? BDD is it is basically a natural extension of the TDD. Some people will say this is a superset of or mutation or something like that. Some other will say that it's entirely different thing, but the base idea is still the same. We are writing tests to make sure that the code works, but the approach is a little bit different. That's, I would say, is the biggest difference. Because in TDD, we are testing internal mechanism of the code. We are testing implementations. We are testing if the method returns what we want it to return. With BDD, we are trying to check if the code and application in general works the way that we want it to work, not internally. We don't look at the mechanisms inside the machine. We are looking at the machine. We are not looking at the single elements of that machine. We are not looking under the hood. We are looking at the machine as a whole. We are looking at the buttons. We are looking how it will react to our action or maybe some internal actions. So basically the behavior of the machine, the behavior of the systems is more important than the way that those systems were implemented, those features were implemented. It might sound like it's basically the same or pretty similar, but there is a little bit of a difference, which is why one of the reasons why I'm even giving this talk, because a lot of people will try to explain those differences and a lot of them will succeed, but I believe there is still not enough of them. And the concept of differences between TDD and BDD is still a little bit too hard. It's still a little bit too vague, at least sometimes. Okay, so simple example. Let's say we have a game. Let's say we have a Diablo-esque game. And we have a game module, which consists of most of the game's logic. And we have the method called entity killed. And basically, when the player kills the monster, then the game checks if that monster had should drop something, some item, or maybe in more general terms, if the monster should give player any reward, because there can be XP, then can be something else. And then if there is like a random item attached to the monster, module responsible for items will create that item based on the data passed from the monster, and then we will give that item to the player. Now, this might sound a little bit complicated, but it is basically this, if we remove all the noise, yes? Basically, we have 4 modules, and those 4 modules have 4 tasks to, one per module, yes? We kill the entity, the monster, and then we check for that monster if there is any loot. Then we pick that item. We pick item based on that information if there is any loot, and then we give it to the player. It's like 4 instructions, but those instructions basically talk with each other to retrieve all the necessary information, because items module needs to know what item it should give to the player, and the player module needs to know what item also it should give to the player. So basically we have 4 parts of the system that all talk with each other and all require something from each other. And then, yeah, it should just work together, yes? It's a little bit more complicated than a simple method that adds to number together, as you can see. So the simplest test in more, let's say, TDD oriented version would be that if we just check the length of the inventory array in the player module, because there is probably an inventory array or an inventory object or something like that. Then we activate the entity killed method and we check the length again, and we then compare. If the length of the array is bigger than it was before, then the item was created and passed. Now, we don't really check here if the item was of the correct type, if there was 1 or maybe 2 items. We didn't really check for the little details that are under the hood, because there is a chance that, for example, that item will have the same ID that one of the previous items. There's always a chance for that. But at the same time, that doesn't really interest us. I mean, it's the topic for other tests, but the base idea here at this very moment is that we just check if the module responsible for giving player any random item from the monster works. And as you can see, we just call here the entity killed method. We just call the first method from the chain, and then we check if the results are as we predicted, because yeah, under the hood, all of those methods are called, all of those methods will do their stuff, but the end result should be that player will have another item. And so in this first week test, we check for that, and it's all fine and good, but it's also very implementation specific. Now, let's not kid ourselves. To some extent, we have to check the implementation in the code, because we have to let's say ask the code about if it works, and we have to ask based on that that implementation. But there is a degree at which we can do that. We can be more specific, we can be less specific. In this situation here, we are very specific, because we are saying, hey, give me the length of the inventory. So we are assuming that the inventory is array, but the inventory can also be an object, just a list of items when the key is ID and the value is the data of the object. And at which point this test will fail, because object doesn't have that. We'll have to ask differently. Maybe we should then add a specific method like get player items or something like that, and then check the length of that. But that still binds us to the implementation a little bit too much. But as I said, there is a degree that we have to know at least a little bit about that implementation, but there are ways to make it a little less coupled with our tests. Because in this specific moment, if we change the inventory from array to object, then this test will fail. We will have to rewrite it. So, but yeah, this is the TDD version. We are looking under the hood. We are checking how this is implemented, and we are testing that. For the more BDD version, let's say, first of all, you may see that we change wording a little bit, which is also very important here. Like here, we are asking if the game module gives player an item when the situation is like the monster was killed. Yes, in this specific situation, when player killed a monster, give them a reward. It might sound not that different, like what happened here. Nothing important, but it is actually important, because we change the focus here. We change the focus from the code, from the game module, to the player. We are switching perspective. We are not looking under the hood. We are looking at the machine itself. We are looking at how it will react to our actions. And that, as I said before, when tests are here to force us to think about how the software should work, about edge cases and such, changing the wording of those tests will also do that, because now we are not thinking. At this point, we shouldn't think about the code. We should think about the results of the code, which might sound like the same thing to a lot of people, but it really isn't. And as you can see, in this specific situation, we have probably a screen where we have items of the player. So we get all of those items by document query select for all. We kill the entity, we get a new list of items, and we check if the length of that items is the same as previously. Now, one can say that this is also tied to implementation, which is true, because you have to have a component or a view with the items, and those items will probably have a class or an ID, so you can grab and check that list. And that's all true, that's all fine. But in this specific case, we also moved the moment when we are checking, because in the previous example, we were checking the let's say 1 or 2 levels lower implementation. We are checking inside the machine. We are checking how there all of this works. Here we are checking what the end user will see. We are checking what the player will see. And what the player will see. What player will see a list of items. The player will see a list of items on the screen, boxes and names, something like that. And player is not really interested on what is under all of that. He's not interested in how it works exactly. He's interested that there is a list of items, and when he kills the monster, the list of items is bigger. So it's still testing implementation to some degree, but it's more here it's more about the results that are presented to the end user than the results that are presented to the programmer. That's also a very important distinction, because for the TDD, this specific example especially, we are seeing what developer is seeing, because he sees like the player module inventory is an array, so he checks the length and he checks the length again. When it comes to BDD version, this is what user will see. He will see a list of items, and he will see a list of items with another 1 or 2 items more. And based on that, you can say that, yeah, this system works. So this is the second very important difference between those two approaches. As I said, perspective of the developer and the perspective of the user. That might sound also very inconsequential. Like, what's really the difference? What's the point of that? Well, the difference is very easy, because most I would say a lot of developers, a lot of people building some specific piece of software won't really use it for whatever reason. There is a chance that, for example, when you build an internet shop, you will maybe once or twice use it to buy something. But there is a good chance that you won't even bother, or that you won't even have a chance to do that, because maybe there is a test, maybe there are testers to do that. Maybe this is not the type of shop for you. Maybe you don't have time. Maybe you have other shops in your mind, etc. And even when you test if your shop works, there is a chance that you won't really use it as a user. You will use it as a developer. You will click a button, you will check that, you will see that the system works, and you will be done. That's it. But only after you use that shop as a user and ask yourself, is it really comfortable to use this shop? Is it really sane to use this shop? You will then understand that maybe something... I hope you didn't hear that. My dog decided to bark a little bit. But yeah, only after you use the shop as a user, you will probably see that some things are not working, or some things are working better than expected. And this is exactly the same situation. This is you testing your code implementation, and this is you testing your whole system and checking if it works as intended. But if you really want, you can also use the BDD approach in the more, let's say, test-driven development way. Because when you really get down to it, in both cases, we do basically the same thing. We are testing. Yes, we are checking if our software works. Well, we are checking it from the different perspectives, sure, but we are still checking if it works, which is like the main idea here, to make sure that it also works. Now, you may be familiar with the idea of given, when, then structure. When you write your tests by saying the base situation with given, then when some action that happens, and then with the result of that action. And as you can see here, this with the player module inventory length, this is the same example of the TDD from the slides before, but here we are using more BDD oriented approach. We are basically checking if the implementation works, but more from the perspective of the system and more with the behavior in mind. Because again, game module gives player an item. When given a game is running, when a player killed a monster, then he should be rewarded. Again, this is more BDD oriented approach, but test code is more TDD oriented. We are checking implementation, but we are also checking implementation for the very specific situation. We are not saying, hey, when I execute this function, when I run this module, something should happen in the code. No, we are saying if on the page or in the game something happens, then the result should be this and this, which is also, you could say, pretty similar, but at the same time, it's also pretty different approach, because again, we are not looking at how the system works. We are looking how the system reacts to some action, to some situation. Yes, and that also may sounds like something that what's about that. Well, it's also but it's quite powerful tool, because again, it forces you to think about what you are doing, to think about how your code works under the hood, or or in reaction to the user input, but how it works nonetheless. Because the thing is, BDD is about, it is often described as the approach, or user-centric approach. Yes, when you do TDD, you test code. When you do BDD, you test user interaction. But the thing is, user can mean a lot of things. User can be like a person sitting before the computer clicking things, but user can also be an API, an internet module that waits for some data. User can be a bunch of systems reacting to keywords or something like that. User can be physical, or user can be machine, basically. Which is why, so yeah, what's the point of all of this? What's the point of even showing you the difference between those two? What's the point of even treating systems as users, or testing in general? So this is a simple pull request screen. It's from Azure. As you can see, it has all the usual parts. There's title, description, reviewers, etc., etc. Nothing really fancy here. And this is something that most people will see during their day-to-day work. There's really nothing else to say here. Just put all the necessary information, create, and move on. Now, this is the exact same form, because it's a form, but with one question added to it. Now, what's the difference, really? Because, yeah, on the first glance, it's just one question, so this is all the difference. No, the difference is more substantial. Just like with the tests, think about it this way. When you see question in the form from the template or put there by yourself, what this question is about? Well, this question is about making you think, because it's directed at you. What parts of the application this PR can break? Since you are filling this pull request, you have to answer this question. And since you have to answer it, or at least you should, because, some PRs don't require that, you have to spend at least a few seconds thinking about it. Asking yourself, okay, is there a chance that this PR can break anything? And if yes, then what exactly can it break? Is it a big part of the application? Maybe it's something small. And you don't even have to spend that much time on it. You can spend like a few seconds and decide that no, everything should be fine. And you write under it, no, zero parts will be affected, and to just move on with your life. But the fact that you still have to sit down and think about it, even for a few seconds, make this question really profound, because at the same time it can help you, or even not even help you, force you to discover that, yeah, maybe there is something wrong with my code. That maybe there is something in the PR that can break some parts of the application. And this is exactly the same situation with tests, because yeah, tests will help you make your code cleaner. make you code better, but tests will also help or force you to think about that code, to think about what this code does, why it does what it does. And you can do it in the, it's not really that important if you do it in the test-driven development way or maybe the behavior-driven development way. But the fact alone that you will have to sit down and think a little bit about what are you doing is really powerful, because let's not kid ourselves, our work is a little bit hard. Our work is a little bit complicated, and it's getting complicated with every passing day. I'm not talking about stacks, technology stacks, about all the external APIs and services that we have to use, of the IDEs, coworkers, of the forms that we have to fill. There is a lot going on. And because there is a lot of going on, the time that we can really spend on our tasks, on our pull requests, on our code, maybe does not shrink, but it's a little bit harder to do good job because of all of the complications of the situations around us. So, and which is one of the reasons, I would say, why we don't write documentation, for example. And suddenly we have to write tests, and the tests ask us to think about our code, to do something that might not be really that easy during the day, or that might happen during the pull requests, because there was quite a lot of situations when I would create a pull request, or I would review a pull request, and I would ask a question another person that created that pull request, and that person would pause for a second or two and would be like, "Oh, I never thought about that." And meanwhile, if there was a test in place, maybe that test would answer my question. Because if you really want to, because you can think about it this way. Tests are documentation. Tests are private, to some degree, private nodes of the developer. Tests are, when you also factor Git in, something of a dev journal, because when you write tests, you are basically designing the system. You are designing a code inside it. I mean, code that will be written later, and you also document it. You say what it should do, why it should do, how it should do, etc., etc. And because of that, I think, yeah, that's for me is first and most important reason why we even should be writing tests. Because as I said, it's hard to write documentation. I mean, let's also ignore the fact that most people are not taught to write documentation. It's very easy to learn how to code. It's very hard to learn how to write pull requests, how to write code, how to do all the things around the code and do it properly. Tests are also in that category. Tests are, writing tests is not that easy. But when you sit down and try, you will probably end up with something like this on the screen. As you can see, there is, given a game is running, when some situations happen, when a player killed a monster, okay, in previous example, he should be rewarded. But then someone sits down and says, hey, but if I'm rewarded, I think I should know that I was rewarded, yes? So we add another test, another use case, another situation that will happen in the final game, because there is a chance that nobody thought about informing the user that, yeah, he got some XP and an item after killing a monster. And only after we sat down and started to write what's going to happen in the game, someone realized that, hey, there should be a situation when the user is informed about that. There should be some jingle, or maybe a colorful message, or maybe some other feedback about that. And then someone else, or maybe the same person, sits down and thinks, okay, what if the player killed a few monsters in a row, like one after another? Maybe he should be extra rewarded, and maybe for that extra reward there should be another form of feedback, which again is something that someone might come up with during the development, during the pre-production phase, etc. But there's also a great chance that when someone writes tests for the application, he will come up with that idea, because he's now thinking about how the system should work, how the application should work, how the game should work. And because of that, he would also have to think about everything around that specific situation that he works on right now. Which is why, for example, he might ask himself, when a player HP value is low, should we do something, like should we warn him? Should we maybe use the health potion automatically? Now, this third block is not it's not really that related to the first and the second one, but it exists here for the because the first one exists and the second one exists, because again, the person writing this test suite was forced to think about what is happening in the game while the game is running, when the player is doing his thing. And because of that, he came up with an idea. Maybe when the HP is low, maybe we should do something to inform the user. Maybe we should help him with that. And so yeah, in my humble opinion, this is the biggest reason why we should even write tests, and one of those, and reason that really is not really that present in tutorials and on material and blog posts and such and such. It's like, it's important to know how to write tests, how to set up jest, etc., etc. But there is a lot of reasons why we even write tests, and this very specific reason, I think, is underrated, omitted too much. So yeah, it's simple conclusion. So behaviors can be about systems, because behaviors is about how something reacts, and that something don't have to be a user. It can be, it can be a system, it can be an API, it can be anything more code related, but not really a person. Which means that we can write tests more with behaviors in mind, but without, but in more, let's say, TDD style. We can mix and match those systems basically. The only if we know if we write those from the perspective of the code or from the perspective of the user. When the user is maybe a person using the site or application, or maybe the system using the site, like for example a web scrapper or something like that. And writing tests, tests are about making the application better, making the code better, having a safety net, etc., etc. That's all fine and good, but those are also about making people think, making people ask themselves some questions, to make them look at the code and its implementation and also its use cases from a different perspective. Perspective of the tests, sure, because and which can lead to bad results, to people writing classes that will do some logic and then will return that results of that logic, even though they will not have to in any other situation. But also to write tests, to write software that will actually work in the situation when it should work this or that way. Because there's also another problem. A lot of software is written without end user in mind, or without end user needs in mind, which is pretty easy to do. You just don't have to think about it. But when you write tests, when you write use cases, when you write how systems should behave in response to some action from other system and from the end user, etc., you will be forced to think about that. Maybe are you writing the software that you should write? Are you writing the software that will help the end user, be it a human being or other system, solve his or her problem? Or maybe you're writing a system that does something that you think might help, but and at the end will not. So yeah, why even bother with BDD? Because it forces you and helps you, forces us and helps us to write better software by using different perspectives, by just forcing us to write about it. And when we write about it, we think about it. And when we think about it, we easier find places that this software will not work, or it will work better if we take something into consideration. So yeah, that's basically it. Are there any questions about all of this? Are there any questions about BDD, TDD, about approaches, about anything related to all of this? If yes, then don't be shy, just type them in the comments. We have a few minutes to do that, so take your time. Okay, I don't see any. So this is the moment because it's the moment in most of situations like that when I would like to sell you something, and I won't gonna lie, I'm also gonna try to do it here because we will have pretty soon, I think it's next week, we will have a little workshop about using BDD and TDD also, because as I said, it's not the same thing, but they are related to themselves. So we will have a little workshop about how to use TDD, how to use BDD, how to write tests in general, how to write software in behaviors in mind. For people who either know something about those topics but aren't really exactly sure about the details, or they think that their skill level is maybe not that high and would like to up it a little bit. Uh, uh, as always, as always with things like that, the number of attendance is limited. We also want to put them in a little groups because writing tests and writing software with behavior in mind is all fine and good, but when you do that alone, the end result will be, I don't want to say always, but most of the time will be a little bit worse because, as I said, BDD and TDD is about perspective and writing, and when you have more than one people on the team, you will have more perspectives, and because you have more perspectives, then probably the probability of having a better software is also a little bit higher. So yeah, this will be a little workshop about how to write software using more BDD and TDD approach, but this also will be about how to write that software and also tests with with bigger team in mind, with more people in mind. And yeah, we will have that workshop next week. If you want to know about it, or if you want to know about our company or all other webinars, because there will be other webinars about writing software in general. I mean, it will be about writing software in JavaScript, not kid ourselves, but it will be also about how to write better software in JavaScript, how to write better software in general, to some extent. There will be some examples how to make better software of the, let's say, worse software. Yeah, it will be more webinars about the craft of writing software, let's put it that way. And if you want to know when, why, how, etc., etc., and if you want to later take part in one of our courses, because we will have some in the near future, as I said, and we'll I mean near and far future, let's get ourselves, then please subscribe to our newsletter. We will be so you will be up to date. We will send in via this newsletter informations about the next webinar. We will also send information about our workshops, about positions that etc., etc. So yeah, if you are really interested, if you want to know when the next webinar about software about writing better software will take place, then please subscribe. You will be up to date. So yeah, I think that's it. We will have some time, but I'm out of material and there is no questions, as you can see. So again, quick recap. As I said, behaviors, BDD, behavior-driven development. Behavior can be about systems, and you write tests not only to make our software work better, and not only to be sure that our systems work, but also to design those systems, to think about those systems, to make those systems better by spending more time on them. Because it might not work, but there is a great chance that even thinking about them will make that software much better. And if you want to know more about that, if you want to train with us how to write more behavior-driven software, if you want to also to be in touch, stay in touch with us and to know when the next webinar or maybe some workshop will take place, please subscribe to our newsletter. We will inform you as soon as it's possible. So yeah, I think that's it for today. So thank you all for participating. I hope that this was at least a little informative and you learned something new. And I hope I will hear from you pretty soon. So have a nice day and goodbye.